In this video, I'm going to go over a quiz that I gave on basic probability. It was really sort of an introduction to probability. So of course we will cover the notation that's used with probability. I will show you how to interpret a Venn diagram and do some calculations of the probabilities of A and B, the probability of A or B, the probability of A given B, and a few other things. But before we get started, here are some basic fundamental concepts that you have to have very clear in your head. Sometimes we will talk about the intersection of two sets. And sometimes we will talk about the union of two sets. All right, we didn't actually use these words very often in my class, but nevertheless, this is what we were discussing. An intersection is when you're going to use the word and. You're talking about one set and another set. A union is when you're using the word or. So, the first thing you need to know is that this is the symbol for and, sort of an upside down U. And this is the symbol for or. It's sort of a right side up U. Now, when you're looking at a Venn diagram, and is very picky. If this circle represents one set and this circle represents the other set, here's sort of the universe. And this set and this set, we're talking about the overlap between these two sets. So and is all about the overlap. Okay, on the other hand, if we're talking about, if we look at a Venn diagram and we're talking about or, so I want to talk about this set or this set, now we're not talking about the overlap. This time, we just want all of both sets. All of both. So if I were to highlight that, it would look like this. Okay, so another key concept as you look at these two pictures, notice that or is more, okay, and is just the overlapping part, but or is all of both. So sometimes we will say that or is more. And conversely, and is less, even though it doesn't rhyme. And is less or is more. So keep that in your mind. The other concept that you're going to need to know is the concept of a complement. And in this context, I'm not talking about saying something nice about someone. The complement of a set is everything except a set. So not A is the complement of A. Now, there are a bunch of ways that this is written. All right, not A is the same as this, okay? A with a little apostrophe or whatever you want to call it, like a prime. This means not A. Sometimes you will see A with a line over it. That means not A. Sometimes you will see A with a little C, right, for complement, a complement. In all of these cases, if I were to show you a Venn diagram, all right, if this is set A, okay, I'll just put the A in here for a minute. If this is set A, then not A would be everything that is outside of A. Okay, so everything out here would be not A. I'm going to pause the video because it'll bore you watching me draw this in. So this would be a diagram of not A, or the complement of A, everything except for A. So those are the basic concepts on which we will build to be able to do these problems. Okay, so let's get started. For the first couple problems, we're matching up English phrases with these mathematical symbols, these symbols of probability. And so we have to see which one it is. And so here you see the phrase, girls who are not freshmen. So for a moment, let me focus in on the not freshman part. So we just spoke about that. All right, not A is like A prime. So as soon as you see not freshman, that's going to narrow it down to the ones that have not F in it. So the answer cannot be A, because it doesn't say not freshman, and the answer cannot be C. So it's either going to be B or D. So the only difference between these is the first one has the OR symbol, and the second one has the AND symbol. So the only question is, are we talking about the overlap of these two sets, or are we talking about all of both? Okay? So the easier one to understand is the overlap. When we say girls who are not freshmen, are we saying that, or are we talking about girls and people who are not freshmen? Are these two things happening at the same time, or is it like one or the other? Well, because it says girls who are not freshmen, you're picturing one person, okay? A girl who is not a freshman, that's a girl and not a freshman at the same time. So we are talking about the overlap between girls, well, and not freshmen. The picture doesn't really match very well. But we're talking about the overlap between these two sets. We want to be a girl and not a freshman at the same time. So we will be a girl who is not a freshman. So that's why the answer is going to be D and not B. Okay? Girl and not freshman is a girl who is not a freshman. Okay? Moving on to number 2. Which of these represents students who are neither... You know what? Go back to number 1 for a second, because when I gave this quiz, a lot of people did pick B. So just understand, here's how it would have been worded if the answer was B. It would have said students who are either girls or freshmen. All right? It really would have had the word or right in it. Students who are either a girl or not a freshman. I should have said not. Okay? Anyway, problem number 2. Which of these represents students who are neither sophomores nor girls? Okay? So if I had seen, okay, so we have neither sophomores nor girls. So if I had seen not sophomores or not girls, I would have picked that for sure. All right? Because it's got to be neither one, neither sophomores nor girls. Look at it this way, though. I think it'll be easier if we look at a Venn diagram. Okay? Maybe I need to draw a new one. Okay, here's a quick diagram representing the overlapping sets, sophomores and girls. Now, if I said, hey, look at the set sophomores or girls, like I showed you on the other slide, that would be all of both. All right, sophomores or girls would just be all of both. So that would be like this. Okay, so that's sophomores or girls. Now, what if I modified this and said not sophomores or girls? Well, remember, we learned that not a set is everything except for this. So, not sophomore or a girl would be everything outside of those two circles. Now, if you're one of the people out here, it should be easy for you to see that you're neither a sophomore nor a girl. You're outside of both of these two circles. So in other words, this statement, not sophomore or girls, is the same thing as saying neither sophomore nor girl. Okay? This is the same, these two mean the same thing. Okay? In fact, at the very beginning, when I saw the phrase students who are neither sophomores nor girls, I had wanted to say not sophomore or not girl. Okay? Because that matches perfectly. But putting that not on the whole set, sophomore or girls, it means the same thing as not sophomore or not girl, as you can see in the diagram. So I said all that to say that the answer has to be C. Okay, not sophomore or girl. Okay, problem number 3. Which pair of events are mutually exclusive? Okay, mutually exclusive means two events that have no overlap to each other. All right, if I put the Venn diagram, it would have to look like this. All right, for example, if I had freshmen and I had juniors, you cannot be a freshman and a junior at the same time. There's no overlap. There's no freshmen / juniors. So these would be mutually exclusive. All right, sets that overlap, like sophomore and girl, because you could be a person in this area who is a female sophomore. These are called overlapping. Okay, so which would be mutually exclusive? Can you be a girl and a freshman? Yes. Can you be a freshman and a sophomore? No. You're one or the other. So this is your mutually exclusive. All right. Problem number 4. Roswell has 2,248 students. There are 510 freshmen, 1,128 girls, and 261 freshmen. 261 freshman girls, right? That's the overlap between these two sets. Sue says, Sue sees the question, how many Roswell students are freshmen or girls? And she says the answer is 510 plus 1,128. It's very easy to see where she's getting this from. It says 510 freshmen, all right, and we're trying to figure out freshmen or girls. So, and we know that or is more. Hold on, where's my little... We know that or is more, so we just want all of both. So why not just add up both groups? All right, so we have 510 freshmen, so there you go. Or girls, so 1,128 girls. So there you go. She figures you just add them up. But this is incorrect. Why is this incorrect? Well, the easiest thing to do is to jump down to the Venn diagram down here. And we will set up the Venn diagram correctly, and we'll use it to illustrate the mistake that she made. I think I need to zoom in bigger. All right, is this going to be too fat? All right, let me go to a smaller ink for a moment. Okay. Here's the big mistake that students will make with this information. If you draw the Venn diagram wrong, then that's the mistake that Sue is also making. You'll be making the same mistake as Sue. So here's what you don't do. Hey, there are 510 freshmen. All right. So if this is the circle that represents freshmen, some students will put 510 right here. That is wrong. Do not write that down. And then what are we talking about? Girls. All right. So this other circle represents girls. So then it says 1,128 girls. So a lot of students will put the 1,128 right here. And then it says 261 freshman girls. All right, that's both. So students will put the 261 right here. Let's talk about what's wrong with this before we go any further, and that will explain Sue's mistake. There are only supposed to be 510 freshmen. However, this entire circle represents freshmen, all of it. Okay? That includes the 510 and the 261. So if you draw your Venn diagram this way, with the 510 and the 261 within circle F, then you are really saying, let's see, 510 plus 261, your diagram is saying that there are 771 freshmen. All right, but that's not what the problem says. So this is too many. So the correct thing to do is to start with your 261, you know, the overlapping part. I guess I need to do that over. Okay, start with the 261 in the middle. But then recognize that when you come to the 510, you need to subtract that 261 to figure out how many are left to be in this area. So you need to go 510 minus 261. Okay, so this section is really only 249. So this is 249. Similarly, there's supposed to be a total of 1,128 girls. Right now we have that many, and then plus another 261. So that'll be too many in the girl circle here. So we need to subtract the 261 to find out what number to put in the right hand side. So we need to go 1,128 minus 261. So that's 867. So this needs to be 867. Okay? It still makes sense though, because if I look at the whole circle of girls, that includes both of these numbers, and that does add up to the 1,128 that we wanted. All right? So, the problem is, so here's the mistake that Sue made in a nutshell. When Sue added up, when Sue used the, what was it, 500, when Sue used the 510, okay, that was the 249 and the 261 right here. She was really adding both of those numbers together and using that. But then when Sue used the 1,128, that's the sum of these two numbers right here. So that's like adding the 261 and the 867. In other words, she counted the 261 twice. All right, once included in the first number and again included in the second number. All right, so she's double counting the 261. That's too many. So that's basically what you need to write in your explanation. Something about counting the 261 twice. Okay, so here's a really nice explanation for you, all written out. The 510 freshmen includes 261 girls, as you can see. The 1,128 girls includes 261 freshmen. So Sue is obviously counting the 261 students twice. So looking at the Venn diagram below, instead she should have simply added 249 plus 261 plus 867, and that would be the number of students who are freshmen or girls. Alright, that way you're not counting the 261 twice. Okay, now let's go on and finish off this Venn diagram for fun, because there's another Venn diagram problem coming. See this little question mark? This was a common mistake I saw. A lot of students left that blank. So there should be a number out here. How do we figure out what that number should be? Well, looking back at the original problem, it said that Roswell has 2,248 students. So I'm betting that these three numbers do not add up to 2,248. So there's going to be leftovers. Okay, so if we do 249 plus the 261 plus the 867, alright, that gives us this. So that's less than the total. So now let's subtract. We'll take the 2,248 and we will subtract the 1,377. And that leaves 871. So to complete our Venn diagram, we should really have 871 out here. Okay, keep that in mind when we do the next problem. Alright, this video is already 22 minutes long, so I'm going to stop the video here, and we'll pick up with number 5 through 8 on the next video. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.